Hello friends, welcome to the Pharma Notes YouTube channel. Today we are going to learn how to draw tetracycline antibiotics in a very simple way. So I insist to watch this video till the end so everyone can be able to draw these tetracycline antibiotic structures in a very simple and easy way. So let's start this simple video and special video for everyone. So look at this caricature of caterpillar who is containing of the four rings, and just consider that caterpillar we are going to hold at the second ring with the help of forceps, and in the last ring we are piercing the needle into the caterpillar so that it will feel like the painful, and it will make a sound of ouch ouch. So at the end we are drawing the OH structure here in the last ring, ouch. And let's see at this bottom side there are the legs of this caterpillar, the single leg, forward leg, backward leg, forward leg, backward, and here is its sex organ. So by considering this caterpillar, imagining this caterpillar, we it will help us lot to draw the tetracycline structure. So let's draw the tetracycline structure. After that we will draw the another member of this tetracycline family. So let's focus on this tetracycline structure. It will contain the caterpillar, four ring caterpillar. Here we are holding this caterpillar at the second ring with the help of forceps. This is the forceps. At the forceps one end we have to draw, one end we have to draw OH group, and another end we have to draw the CH3 methyl group. And here at the fourth ring we are piercing a needle, so just draw this needle like structure, and N will uh, inform us about the nitrogen. Needle N for nitrogen, and nitrogen is binded to the three compounds as it has a three vacancies, so one for this fourth ring and two here which are already attached with the methyl group. Okay, and so let's see the caterpillar legs are there at the bottom side. This is forward leg contain OH, here is the double bond O, backward leg once again forward leg OH, and backward leg double bond O, and here is the sex organ like structure OH we have to draw here. And as we are piercing this needle in the fourth ring of this caterpillar, it is painful for that caterpillar and it will make the sound of ouch. So we have to draw here OH functional group attached at this ring. And as this whole structure is drawn very well and clearly correct one, so we have to make a right mark here at this part. We have to make the right mark here and draw the NH group here and double bond O at the bottom side. Okay, so this is the perfect structure of the tetracycline. Here this ring is fully double bonded, so here is the we have to draw the circle inside this ring, and here is double bond and here is double bond. Okay, so this is the tetracycline. I hope you all can be able now to draw this structure in a very easy way. So just once again I have to repeat this. This is the caterpillar containing the four ring. At the second ring we are holding this with a forceps, and forceps at the one end of this forceps we have to draw the OH group, and another group there is a methyl group. In the fourth ring we are piercing the needle, so N will help us to identify the nitrogen here of needle. So it will already attached with the three members, one here and two are attached with the methyl groups. And as we are piercing the needle, it will makes the painful sound, that is ouch. So OH we have to draw here, and at the bottom side we have to draw the legs for this caterpillar. So forward leg OH double bond O, backward leg forward leg OH, backward leg double bond O. Here is the sex organ OH we have to draw, and as this structure is the very correct, so we have to make the sign of correct here, right sign, and draw the NH2 group, and at the bottom there is the double bond O. Okay, so let's go for the next another members of this family, tetracycline antibiotic. So we will compare this tetracycline with the oxytetracycline. Okay, so what is the difference between tetracycline and oxytetracycline? It's just the difference of this OH group at the 5 position. Okay, remember this 5, 6, 7 positions while studying the tetracycline structures. These are the very important positions, 5, 6, 7. So in a oxytetracycline we have to just add a OH group at the 5th group, so it will be oxytetracycline. In a tetracycline ring we have to add OH group at the 5th position, so it will be oxytetracycline. So here I draw the OH and I simply write the oxytetracycline. So this structures resembles the oxytetracycline structures. Okay, so as we are expert in drawing the tetracycline structure, so this is the oxytetracycline. Very simple, just add the OH group at the fifth positions. So let's go for the another member, that is doxycycline. So while pronouncing this doxycycline, it will help us, it will give a clue of dogs. So these dogs will help us, it shifts that OH group at the sixth position to the fifth position. Dogs, it shifts the OH group to the fifth position and it will be a structure of doxycycline. Okay, so we remember the tetracycline structure. At the just forceps, we are holding this caterpillar at the second ring. It is forceps contain the OH and CH3 group. So one OH group, hydroxyl group, will be shifted to the fifth position from sixth position, and it will make the doxycycline structure. And who shifted this OH group? That means dogs. Okay, as the doxycycline gives the clue about the dogs, it will shifting this OH group. So just shifting of OH group makes the structure of doxycycline. So we will be very expert in drawing the doxycycline also, oxytetracycline, and here is doxycycline. We clear two structures of this tetracycline family. So next member is the chlortetracycline. Chlortetracycline, it's a very easy another structure of this family, tetracycline. So as a chlortetracycline names already indicates that here is a chlorine. So as the chlorine name in the tetracycline, it will indicate that at the seventh position there must be a chlorine. So just add the seventh position chlorine, so it will convert the tetracycline into the chlortetracycline. Okay, so we will be very familiar to this chlortetracycline also. So we will go for another member of this tetracycline family, that is methacycline. So here is some important changes in the tetracycline structure. One is the shifting of this OH to the 5 position, and at the 6th position there is this methyl group. It will loses the one hydrogen H2 member, and it will make the double bond here. So one hydrogen from here and one hydrogen from here, that is H2, are minusing from here, so it will be converted into double bond CH2, that is methylene group. So it will be converted into the methacycline. Metha, it will indicate the methylene group and the shifting of this OH group here. So we remember the doxycycline, that is dogs will just simply shift this OH group from the 6th position to 5th position, and in methacycline we have to make another change, that is the one H2 molecule, from one H2 molecule from CH3 one hydrogen, and from here one hydrogen is replaced and it will form the double bond here, so it will create the methacycline. So difference between methacycline and doxycycline is the differ by the one H2 molecule. Okay, and tetracycline, metacycline also differ by one H2 molecule. So we will also familiar now with another member, that is methacycline, and we are go forward for the another member of this family. So here is a macrocycline. We have to learn about the macrocycline. So we are just going to expert in drawing the tetracycline. So macrocycline is very easy, as I already told you in chlortetracycline. As a chlor word, remember us about the chlorine, which is placed at the position 7. So macrocycline also contains the chlor word, which will inform us to draw the chlorine at the 7th position. So we already draw, and macrocycline, this may will inform us about the metacycline structure. So metacycline we are already drawn, that is the double bond CH2 methylene, and hydroxyl group will be shifted to the 5th position, so it will be metacycline, and at the 7th position we are adding to chlorine, so it will be macrocycline. So metacycline plus chlorine, it will inform about the macrocycline. So again we are learn another member and go forward for the next member, that is dimeclocycline. So we know the tetracycline structure with the help of caterpillar, forceps and needle, and this is the right mark and out sound of the pen. So dimeclocycline, dime word indicates the demethylation. We have to delete this methyl group from the 6th position, as the dime indicates the demethylation, and so it remember us about the deleting this methyl group. And the chlor word, we are informed that clue word inform us that we have to place the chlorine at the 7th position. So it is clear cut structure of the dimeclocycline. As we are going to delete the methyl group and adding the chlorine at the 7th position, it will be convert the tetracycline to dimeclocycline. So we are another members adding in our knowledge, that is dimeclocycline, and going to add the new member, that is Rowley's cycline. What is this Rowley's cycline? So we remember the structure of tetracycline as the caterpillar containing the 4 rings. Second ring we are holding with a forceps hub. One OH end and CS3 end is there, and legs are there, forward, backward, forward, sex organ here OH. And as we are piercing the needle here in the 4th ring, it will make the painful sound, that is ouch. OH we have to add here and make a right sign as the structure will write, adding the NH2 group and at the bottom double bond O. So this is the tetracycline. But when we are putting this, replacing this hydrogen from this NH2 group, we are replacing one hydrogen with the help of pyrrolidino methyl group. Pyrrolidino methyl group. So it will be converted into Rowley cycline. So see, this group names indicate that the pyrrolidinomethyl. Okay, this is pyrrolidine ring and this is the methyl group. So pyrrolidinomethyl group we are adding, and see in the word there is already Rowley comes out. Okay, pyrrolly. So this Rowley and this tetracycline cycline. So pyrrolidino we are taking this Rowley, and from tetracycline we are taking the cycline. So Rowley cycline. So here we are very familiar with this Rowley cycline as pyrrolidinomethyl group substitute at the NH2 position. It will convert the tetracycline to the Rowley cycline. So next, another member of this family we are going to add in our knowledge, that is minocycline. So in a minocycline, this word indicates the minimum. So we are making this tetracycline structure minimum by deleting these groups or the forceps at the 6th position and making the 5 and 6 positions vacant. And at the 7th position, we have to make some copy paste command, that is this needle we are piercing in the 4th ring. We are copy paste this needle at this 7th position also. So this needle is here also and at the 1st ring also. So it will makes the structure that is minocycline. Okay, so we will going to make this tetracycline minimum by deleting the 6 positions groups and 5 position remain vacant, 5 and 6 remains vacant, and just copy paste this needle at the this 7th position also from here. So it will make the minocycline. Tetracycline is converted to minocycline. So minimum structure and copy paste command will convert the minocycline compound. Use as minocycline compound from the tetracycline. So just overlook all the data as we already studied from the tetracycline, as comparing the tetracycline with the another members of the tetracycline antibiotics. So we learned doxycycline, oxycycline, metacycline and maclocycline. All these compounds contain the hydroxyl group at the 5 position, and among these compounds oxytetracycline contains hydroxyl group also at the 6th position. 5 position it will contain, and also at the 6th position it will contain hydroxyl group. And another group, this doxycycline, metacycline, maclocycline, contains only one hydroxyl group at the 5th position. Another members of this family, that is dimeclocycline, Rowley cycline, tetracycline and chlorotetracycline, contains the hydroxyl group at the 6th positions as in tetracycline. Okay, and in minocycline we are making the vacant position 5th and 6th, so there is no hydroxyl group in this minocycline compound at the 5 or 6 positions. Okay, this is the minimum structure. And oxytetracycline, as I already told you, that it contains the 5 and 6 position, both position contains the hydroxyl group. Okay, so hope you all will understand how to draw the tetracyclines and their another members. About 8 to 9 structures we learned already here. So hope all you are like this video. So make comments and just subscribe our channel, so that we will put up the more informative and more tricky material for you in the next video. So thank you.